Sorry about that. Kind of got cut off from the last video. So we wrote in number 12, we wrote the cosine equation. That was y equals 3 cosine 2x. The 3 being the amplitude and the 2 being the b, the number of full cycles in 2 pi. And then we're going to write that in sine form, and it's the exact same equation. You change cosine to sine. The 3 and the 2 are still there, but there's a phase shift to the left by 1/4 pi, so we put that plus 1/4 pi there. So here we added a c that was pi over 4. All right, let's go back to here. On number 14, given that the cosine is 0.1427 and theta is between 0 and pi over 2 radians, what is the approximate value of sine? Very similar to these guys, number 10 and number 11. I'm going to take a slightly different tact here. So between 0 and pi over 2 is 90 degrees. So on your unit circle, that's from 0 degrees to pi over 2. So, or 0 radians, pi over 2 radians. That's the first quadrant. So you know everyone's going to be positive here. So you know the answer. It's going to be a plus number. Whoops. Let's go over here. It's going to be a plus number. Now I'm going to use the Pythagorean identity. Remember, sine squared theta plus cosine squared theta equals 1. Now I'm going to make a substitution. I know what cosine of theta is. So if I go that 0.1427 and then I square that, then I have sine squared theta plus equals 1. So what we can do is just subtract that number, and I'm going to let the calculator handle the decimal. That's why I'm not multiplying it out. You can multiply it out if you really wanted to. Okay, so this is going to be sine squared theta equals 1 minus 0.1427 squared. Now if I take the square root of both sides, I'm going to get the sine of theta. I'm running out of room. Let's go back to Desmos here, and it's going to be, we need the square root 1 minus 0.1427 to the exponent of 2. So that's giving me a 0.98976. On that 6, let's round up 1, so 0.9898. How's that for one? And then let's go back here. So we wanted the sine, so we're going to say sine of theta equals 0.9898. And remember we said it was a plus, so I'm just going to leave it like that. Almost there. I know this has been a long haul, so I appreciate you hanging with me. So given that the sine of theta is negative 0.7149 and theta is between 3/2 pi and 2 pi, what is the approximate value of cosine? So 3/2 pi radians to 2 pi radians. Now this is the fourth quadrant, and we're looking for the cosine. So the cosine are the x values. Notice all the x values here are positive. So we know our answer is going to be a plus number. You just write that, and you just have to remember, so our cosine value is going to be a plus number. So I'm going to use that same Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Well, this time I know the sign. Put this in parentheses, that negative, or you're going to have a negative issue. I'm running out of paper here, strategic lack of planning on my part. So I'm going to say cosine squared theta is equal to 1 minus, now this is a negative 0.7149, and that's going to be squared. And remember, I don't want cosine squared, I want cosine, so I have to take the square root of both of them. So we're going to say cosine of theta equals, let's put this all in the calculator. So 1 minus 7149, and it's squared, so it's 0.69922, so that 2 is going to stay there, so 0.6992. Now, I said it was a plus number before. It's kind of hard to remember to check your sign at the very end. So always double check your sign. Yeah. So show all the ways you can calculate tangent of theta. Well, you could do it on the calculator. You can say tangent of theta equals sine theta divided by cosine theta, or you could say it equals tangents the opposite side divided by the adjacent side. I don't know, maybe there's another way that I'm not thinking about right now, but I think those are the two big ones. Now the Pythagorean identity, so it's written up here, I already wrote it for you, sine squared theta plus cosine squared theta equals 1. Now you can solve for this one, or you can solve for sine or solve for cosine. So this one will have some different forms, and I'll let you play with that. So have a great one. Good luck on the test. Remember, test is Tuesday.